next speaker is Maria Whiter, who will be giving us a very cool talk about searching for asteroids in citizen science projects. So Maria, if you're here and ready, you can go ahead and share your screen and give your presentation. Thank you so much.
Hi everyone, can you see my screen?
Yes.
Okay, great. Then, hi everyone, my name is Maria Wicher, and as a member of Polish Astrobiological Society and Polish Society of Amateur Astronomers, I would like to present citizen science projects and citizen scientists' contribution to asteroids discoveries and observations from the perspective of the citizen scientists and also a high school student involved in each of them. Citizen science, also known as community science, is a form of research that actively involves volunteers from all over the world in real scientific research. Citizen science is also a social movement and type of science education. It is considered to be a type of new technology belonging to the swarm intelligence. It is defined as inclusive science as well. Although citizen science developed only at the end of the 20th century, its defining characteristics are not entirely new. Before the 20th century, science was often a pursuit of amateur researchers, gentlemen scientists such as Isaac Newton, Benjamin Franklin, and Charles Darwin. However, some even consider Leonardo da Vinci to be the first citizen scientist. Citizen science is used in a wide range of areas, including ecology, medicine, and astronomy. In recent years, the work of professional astronomers has been increasingly supported by amateur astronomers and citizen science projects. Thanks to active participation of citizen scientists, it's possible to effectively collect, analyze, and process a huge amount of different data. In the field of asteroid search and observation, citizen scientists can currently help professional astronomers in 3 projects: International Astronomical Search Collaboration (ADASSx), the Daily Minor Planet (TDMP), and Common Impacting Asteroids (COIAS). The results of citizen scientists' observations and discoveries, as in the case of professional astronomers, are reported to the Minor Planet Center (MPC) when they are subsequently processed and then published via the Minor Planet circulars.
Maria, I'm sorry to interrupt, but your slides aren't advancing on Zoom. We're just still seeing the general PowerPoint window on the first slide.
Well, you can see my screen, right?
We can see your screen, but it's just the PowerPoint window. It's not the slides full screen.
Okay, so maybe I'll try this way. Can you hear it? Can you see it now?
Yes, that looks good. Thank you so much.
Perfectly. My first experience with observing and searching for asteroids was participation in the International Astronomical Search Collaboration Project. It is aimed mainly at school youth. ADASSx participants use images taken by 8.8-meter diameter pan-star telescopes. Citizen scientists working at ADASSx have the potential to find asteroids that have not been detected by automated detection systems. During the so-called asteroid search campaign, citizen scientists use specialized software for astrometry research called Astronomical. Citizen scientists create an animation consisting of a sequence of 4 images, analyze it, and then generate reports that descend to the ADASSx. Objects measured by citizen scientists but not detected by automated detection systems received preliminary status. These are detections that appear to be valid but have not been fully verified by the Minor Planet Center. Asteroids that may be potential NEOs are reported to the NEO-CP, NEO confirmation page, and the other observatories can confirm their existence. Other new objects are placed in the isolated tracked file at DF when they await the opportunity to be combined with other new observations. Discoveries verified by the MPC are given a provisional status pending further observations and confirmation. A 2023 Planetary Śląski team, of which I was a member, took part in another international astronomical search campaign. Our team's work ended with finding 5 objects that received preliminary status. The MPC later issued 2 supplements to the circulars in which 2 of our 5 found objects received provisional status. Here you can see a photo from the ceremony of presenting the discoveries, confirm the certificates confirming the discoveries of our team. Both of these minor planets are classified as main belt asteroids. This slide shows their orbits. Thanks to the IFC, I became more interested in the topic of asteroids, which led me to participation to 2 other citizen science projects, Common Impacting Asteroids and the Daily Minor Planet, where I could further pursue my interests individually. COIAS is a Japanese web-based application developed to enable the search and navigation of minor planets. It uses archival image data taken by 1.2-meter optical infrared Subaru telescope. The aim of the project is to popularize astronomy and to encourage the people to active participation in the scientific research. It is addressed to the wide audience without age restrictions. Interestingly, the name COIAS originates from a Japanese animation, Koizuru Asteroid, Asteroid in Love. This animation is a story of high school students who try to discover asteroids. Scientific and educational importance of COIAS is evidenced by the fact that almost 250,000 objects have obtained preliminary status and over 7,700 of them have obtained provisional designations. My activity as a student scientist in COIAS began in February 2024. To this day, I have reported over 3,300 objects, of which I have been recognized as a discoverer at the provisional level for 288 of them. Currently, I'm the sole participant from Poland in this project, which is a great honor as I represent my country on the international stage. Here you can see an overview of the MBA objects I discovered. However, let's take a closer look at one of them. In COIAS, it's possible to measure very fine objects up to 27 magnitude. I managed to discover an asteroid that is of 25 magnitude. This slide shows its orbit. One of the objects I measured in COIAS 2016 LL100C has been assigned a permanent designation, and I recently learned that I contributed to its discovery. Together with other measurers, I was invited to participate in the naming process of this object. Now I'm looking forward to further discussions regarding the proposed name. All measurer contributors have been listed on the list of numbered objects discovered on COIAS. Here you can see a sequence of 6 images in which I measured this asteroid. Another project, the Daily Minor Planet Citizen Science Program, hosted on the Zooniverse, the world's largest and most popular platform for people-powered research. The Daily Minor Planet is a project of Catalina Sky Survey, which aims to discover and track main-belt asteroids and near-Earth objects. TDMP, which has been operating since 2023, uses images taken by a 1.5-meter telescope, observatory code G96. Citizen scientists analyzed a batch of data that was taken in the last 12-24 hours in unfavorable weather conditions. The images may be slightly altered. The telescope is equipped with a CCD camera that acquires a sequence of 4 images of the same patch of the night sky, each image taken approximately 6 minutes apart. The volunteer's task is to decide whether an object identified by the CSS automated detection system as a possible asteroid is real, and each potential asteroid is verified by the randomly selected group of 15 participants. My activity as a citizen scientist in TDMP began in January 2024. So far, I have reported over 1,400 objects, of which I have been recognized to discover the provisional level for 44 of them. Shown here is an overview of my interesting provisional discoveries, co-discoveries. Now, I would like to tell you a little bit more about citizen scientists' contribution to the observations and discoveries of near-Earth objects. Analyzing the project statistics, it can be seen that citizen scientists have discovered 10 NEOs in COIAS and 5 NEOs in TDMP. NEOs are an extremely media-friendly group of objects, although few people realize that most of them do not pose any significant threat to Earth. However, such famous objects as Apophis or Bennu have brought planetary defense efforts into the public spotlight. It is particularly worth remembering the case of 2024 Wire 4 discovered late last year, although the possibility of an Earth impact in 2032 has since been ruled out. Media were quick to disseminate the story, often resorting to sensationalism and instilling public fear without providing adequate scientific context. In the photo shown here, I'm holding the fragment of Rebecca meteorite, which comes from asteroid 2024 PX1, the 8th asteroid that humankind has spotted before the impact. The following animation illustrates the motion of the asteroid. Here in turn, you can see a video of the bolide observation, which took place in Poland this year. This event resulted in the 12th meteorite, of which one specimen is part of my collection. So far, I personally have not succeeded to discover NEO myself, but I managed to observe 2 of them. Here presented is 2024 UK6, which I observed in TDMP. It is a member of the Apollo group. Now let me introduce 2019 ILS-1. It was discovered in 2019 and then subsequently lost for over 5 years, thanks to, among others, my observations from TDMP. The object was successfully recovered. This asteroid also belongs to the Apollo group. Of particular note, it is perihelion, which lies close to the orbit of Venus. Both objects were listed on the Neo-Earth Close Approaches website. Sometimes, however, it's possible to find true gems in citizen science projects. I vividly remember the enthusiasm among TDMP volunteers when it was revealed that 2024 RW1, the 9th asteroid discovered before the impact, had been found within a single set of images. Citizen scientists not only discover or observe nearer objects or main-belt asteroids, but also play an increasingly significant role in observing and discovering more usual other objects, such as Jupiter triangles. I have discovered 5 Jupiter triangles, and I'll highlight 2 of them. 2015 IF-OR 488 is a Jupiter triangle that is discovered in archival images in COIAS. Presented here is its orbit. I have also co-discovered such a Jupiter triangle in TDMP, notable for its quite high orbital inclination of nearly 30 degrees. Nevertheless, the real dream of every citizen scientist is to observe or to discover a trans-Neptunian object. It is often referred to as the holy grail of asteroid hunting. Analyzing the project statistics, it can be seen that citizen scientists have discovered over 700 trans-Neptunian objects in COIAS, making it the most successful citizen science project and a global leader in discovery of such objects. Due to their extreme distances and fine magnitudes, TNOs are difficult to spot. That's why it was an extraordinary experience to me to observe 2050 FZ494. Of particular note, it is inclination. It is noteworthy that it's almost 50 degrees. The first trans-Neptunian object I discovered was 2019 EZ8. My observations and name have been published in the Minor Planet Electronic Circular dedicated to this object. I recently learned that I have discovered 3 more trans-Neptunian objects in Koyas. It is particularly remembering one thing, because one of these trans-Neptunian objects has a particularly interesting orbit with a helion at the distance of 237 AU and an orbital period exceeding 1600 years. Towards the end, I'd like to show you a SWOT analysis of the citizen science projects in which I participate, and this allowed me to draw final conclusions. Citizen scientists are the significant part of contemporary science, enabling the resolution of global challenges such as climate change, sustainable development, and planetary defense. Constant technology development and improvements in research methods have led to higher data quality and higher accuracy of results. It is expected that people's interest, including youth, in various scientific projects will continue to grow. This may lead to other remarkable discoveries and popularization of astronomy. In sum, citizen science not only complements traditional research methods, but also plays a significant role in shaping scientific environment. This contributes to understanding the universe around us. Thank you so much, and if you have any questions, feel free to ask them.
Thank you so much for that absolutely incredible presentation. You really accomplished so much, and it's really, really cool to see how these tools are being used. Hogan, do we have any questions from inside the auditorium?
Do we have any questions in the room? It looks like there are no questions here. Are there any online, Vivian?
We have a hand raised from Kelly Fast. Please go ahead and unmute.
Oops, sorry, wrong camera. Go up here. Thank you very much for that. That was really interesting to hear across the different citizen science efforts. I was wondering if you could comment on any strengths and weaknesses that you saw across the different programs that you've been involved in, or do you find that each of them meets different needs when it comes to the citizen science community and students and such? What were your thoughts as you participated in these 3 different programs?
I think citizen science is a great opportunity to young people, especially students and high school students as me, to cooperate and collaborate with people from all over the world who have similar interests and also can contribute to change the world. So it means a lot, and I hope that more citizen science projects will be creating an impact to the science, because that's awesome.
Thank you.
And we have another hand raised from Warren.
Hello, Maria. I don't have a question, but I want to say thank you for being a citizen scientist. In my career, there's various areas of astrophysics which are, I won't say dependent, but citizen scientists and amateur astronomers have made, they make a big contribution to it. And my history is in variable stars, and there was lots of monitoring of variable stars by amateur astronomers and that sort of thing. So anyway, just a word of thanks for your involvement in citizen science, and particularly in you know what you were just talking about. You know, it's fantastic. Thank you very much.
Thank you as well, and that's so nice to hear that you appreciate my work.
We have one question in the room.
You mentioned using the Daily Minor Planet, and you've got a fair crowd of Catalina Sky Survey people in the room. And I find you always learn a lot when you talk to somebody who uses your software. Are there things that you wish were different about the Daily Minor Planet? Things that would make it, you think, easier to use or more useful?
Yeah, that's true, because I think it's a great opportunity to talk about topic that that in which I'm involved, to people that created the project, especially as amazing as the Daily Mirror Planet. So if you actually can hear me, that's awesome.
Come up with anything that ought to be fixed. I find people sometimes they use the software and they don't, there are problems that we don't even know about. Certainly with my software, I see somebody use it and I learned that I made something really dumb. That it should be improved in some way, be a nicer way of putting it. So if you see things that ought to be improved, probably should let us know.
Not sure if I understood the question correctly. Could you please repeat?
I just meant, if you see things that should be improved in, the Daily Minor Planet, things you run across don't work all that, work as well as they should. You should if you think of something later, let us know.
Okay. I think that there are some things to improve, as particularly everywhere, especially in the context of searching for NEOs, because sometimes citizen scientists send alerts that are visible for professional astronomers later than they should be, but overall that is not a big issue, I guess.
Yeah. If you think of something a bit later, let us know.
Okay, thank you.
Are there any questions in the room other than Bill's? Or are there any questions online? I think I saw some pop up in chat in reference to who was just speaking. That was Bill Gray.
Okay.
Looks like there's a question online from Daniel.
Yes. Daniel says, one thing I've noticed with ADASSc is that they don't seem to track provisional objects as much as they do, since from personal research, the published preliminaries either go to a well-known object, a previously lost one, or an actually new asteroid, which is still subject to discovery change upon numbering. My question is if citizen science projects such as ADASSc and TDMP could allow for further transparency on provisional detections so that one can try following up on them with either new observations or archival astrometry. I don't know if that's a question for you or for someone else, but if you have anything to add or answer.
Well, I think it really depends, because it really depends on the project, because there are some cases in which it's really hard to improve, but at the same time, I think that it's a great topic to discuss further.
I could probably speak to this. It's Carson. So I developed the Daily Minor Planet. So on that project on Zooniverse, we do list all of the objects that we have submitted to the MPC. It's a unwieldy list because it is so long, but it's a way for people to keep track of the data on the Daily Minor Planet, so they can still see the image data, and then link to what we sent in. Basically, it links to the WAMO, where are my observations that were sent to the Minor Planet Center. So from that, it should be possible to go do archival pre-covery searches and follow up the objects if you want to get your own images. But just the sheer volume of discoveries kind of hard to keep up with. That list is several thousand objects long.
Yes, and it's also worth mentioning that apart from the results which are published in the Zooniverse website, in the category of results, there are forums in which citizen scientists are discussing various topics, in which also these problems are discussed about recoveries, and how to obtain more provisional codes.
Great, thank you so much. Could we thank Maria one more time? Alrighty, and I think with that, we move on to our last presentation of the session by Kwanzi Ye, who will be giving us some updates on MPEC Watch.